to the next one. So next up, we have part 2 of our morning breakout, Big Data in the Cloud with Peter Meulbroek, Managing Partner and Head of DevOps and Cloud Solutions at RiskFocus. Peter is here with his colleague, Carrie Dim, so you might hear Carrie unmute and answer some questions if they come in. But Peter, so glad you could be with us. Same to you, Carrie, and the virtual stage is all yours.
Let me come off mute. Allison, thank you so much, and really appreciate the opportunity to speak in front of the audience. I'll pull up my deck. Let me see.
And while Peter's pulling his deck up, feel free to drop your questions into chat, and we'll try to answer them as we go through the presentation.
There. Y'all should see my my splash screen. Hopefully you do. So we heard from Bruno a quite broad assessment of some of the things you care about in moving to the cloud, some of the design principles. Today, or with this talk, hopefully we'll get start to drill down. We'll get a little bit more practical and more specific on some of the issues, not only of being in the cloud and processing and analyzing data within the cloud, but in what it takes to actually get there. So just by way of introduction, I should list, because it's not familiar to everyone in the audience, I'm sure, who RiskFocus is. I work for RiskFocus. We're a leading financial technology firm. Our customers are, by and large, financial services companies, mainly capital markets. And we work with these customers in solving some of their hardest problems, both in application development, things such as trading system risk systems, regulatory reporting systems, as well as helping them in their cloud journey. For us, working in the cloud typically means working in AWS, and we've devoted ourselves quite monomaniacally in becoming very, very good at AWS and very, very good at creating next generation systems, particularly streaming systems. We've been around for about 16 years. As to myself, I joined the firm about 5.5 years ago to found the cloud and DevOps practice, and have been the head ever since. Just by way of history, before coming to RiskFocus in New York, I spent about 5.5 years in the Pittsburgh startup scene. So getting a cup of coffee in the Strip is not anything new to me. RiskFocus has offices around the world, but our headquarters is in New York. One of our dev centers is in Pittsburgh, and the other's in Riga, Latvia. So the thesis for the talk is really going to be around enterprises and some of the challenges and opportunities that enterprises face as they are motivated to analyze data, and particularly move that data for benefit to analyze in the cloud. For the group of enterprises that we typically work with, any kind of analytics requires large scale and, in fact, scalability. So the amount of data that they're typically working with is in the hundreds of terabytes to petabyte scale, which requires a scale and storage. Keeping this in a file or somewhere tends to be quite expensive. And so one of the advantages that they seek in moving to a cloud is scale and storage and cost effectiveness in storage. The analysis burdens they take on for various reasons, such as maybe compliance, it may be gathering new insights, et cetera, requires bursty scaling in processing as well. And so the ability to rent equipment rather than buy, use on demand, and take advantage of different pricing mechanisms is of great benefit to them. For them and for us, in this sense, scale becomes cloud, because costs and cost per second or per CPU become the most important metrics, not cost of power, cooling, et cetera. Now, most of, or all of our customers have a tremendous history in dealing with data, in dealing with analytics, and have legacy systems that have built up over decades, in some cases, to process this. Many of our customers start on a mainframe. Others have an enterprise database, something like an Oracle or a Sybase, where years and decades of development have gone into those. And in order to unlock their data, these systems need to be opened. Some of the openings needed are not only access to the databases or data stores, but how do you get it? How do you get data out? So what kind of ETLs do you need? How do you get data safely, securely, and rapidly into the processing center, into the cloud? For these folks, though, cloud is complex. It's not dropping down a credit card and starting up an account, get your first EC2 and off you go. There are many requirements they face from their regulators, from their customers, and from their own internal compliance arms. So security and compliance becomes not job one, job zero. Beyond that, though, we're talking about production systems. So repeatability becomes very important. How do you create an infrastructure and maintain that infrastructure over time? And then validation, of course. So what these firms need to leverage their power, the power of the cloud, and gain greater insight is a place to do it, an environment, automation to create that environment and create the computation necessary, and pipelines to transport data. So we're going to go through in today's talk a use case, but this is one of a family of things we've seen amongst our customers. Typically, our customers have large volumes of legacy data on-prem. And again, this is measured probably in hundreds of terabytes to petabytes. It's a significant amount of data. Success, and many of these folks are successful, is what breeds this complexity in both implementation and access. That architectural decisions that may be a decade old have led to some real complexities in structure. What is universal as well is the amount of business opportunities they face and the amount of compliance burden they face means that their current development teams just do not have the bandwidth to take on new items, especially sort of, to use the phrase, change the bank items. The on-prem or current data teams are very, very focused on run the bank. It's very common, in fact, the most common case where our clients want or needs to gain insight from data. This may be from introducing new product lines, gaining insight in current data. It may be for compliance reasons, both from a trading perspective. An awful lot of regulations started, as we're all familiar, post 2008 big recession, maybe from know your customer type regulations. And the regulatory regime is different in the States, it's different in Canada, it's different in UK, different in EU. And so the burden becomes more and more complex with the scale of the organization. It's also a universal feature among our clients that they aspire to get going fast. They may focus on making the decision for weeks, months, years, but once the decision has been made, there's no stopping. There may be a team of analysts that's ready to get going. There may be a business unit that is desperate or incredibly eager to see results, and they just want to get going. Results in this case always mean production. Production always means complexity. A methodology that we tend to champion to provide the ability to get going fast, to provide, actually to borrow one of the things that Bruno was talking about, the ability to do iterative development, introducing new ideas and getting new ideas, new production capacity, new capabilities, and do it in an iterative fashion is something we've called reorchestration, or providing a data first approach. And I'll get into what this actually means. One of the challenges these folks face is having a legacy system and facing more modern problems. A characteristic of a legacy system, perhaps the most efficient defensive system created that I know of, in fact, was something called the Theodosian walls around the city of Constantinople. I guess we're going to do a little history lesson. The Theodosian walls kept invaders out for 1,000 years until in 1453, the Ottoman Turks invaded and actually innovated, brought a cannon, and destroyed this bastion that had survived onslaught, as I said, for 1,000 years. And so in 1453, the Roman Empire actually fell to onslaught of Ottoman Turks, to innovation, to a cannon. So a legacy system, similarly, in clients we see, is typically on-prem. It's monolithic. Data is stored in a mainframe, in batch systems, in tightly coupled architectures, which was best practice a decade ago when calculation should be as close to data as possible. In more modern network architectures, this is not best practice. Where in a legacy system, there'd be one relational database for all use cases, which was very efficient from a licensing standpoint, and that was about it. Communication between components of these legacy systems tend to be obsolete and require very low-level protocols, such as RPC or UDP communication, on top of older API layers and protocols such as SOAP or XML-RPC. It's really a traditional sort of curtain wall security mindset, which is great until someone brings a cannon. And the world is now full of cannons. I should say, in a more modern system, the defense is flexible. So it responds quickly to innovation and introduces innovation. And a more modern data system in the cloud follows these same principles. So in November of last year, a flexible defensive system under the Steelers beat the Baltimore Ravens 28-24, utilizing a very flexible defense in depth. And similarly, in a more modern cloud-based application, what we've recommended to our clients and what's best practice is, instead of a single monolithic database, purpose-oriented data stores, where communication isn't on a low-level networking, it's something higher level, delivering some benefit actually in the communication infrastructure itself. We've used Kafka very effectively here because Kafka provides benefits around durability, guarantees of delivery. And you can actually move computation out of a monolithic store into something attached to the stream. So you can model where you do computation depending on what the use case is. Security model should be defensive depth. So let's go through an example that is a little bit more hands-on, a little bit more detailed, to explain how a company can go through a transformation to introduce things like reorchestration, or how do you move data to the cloud as a mechanism for moving computation to the cloud, as a mechanism for unlocking data insights. So the client I'm going to talk about, and I won't use their name here, but they're a quite successful firm. They are a firm that is involved in trading equities and commodities around the world in about 13 different markets worldwide. Successful enough that they're really reaching the limits of their scalability of their current on-prem infrastructure. And this is impacting them and impacting their customers in quite negative ways. Essentially, they have too much data. The data is all stored on-prem, and doing things like computation on that data, gaining insights from that data, has grown prohibitive for them. Similar to what I sketched as an outline, they actually have hired recently a new analytics team whose goal is to gain insight from data. That team is, until the migration to the cloud, essentially sat idle waiting for access. The firm is quite interested in insights into trades, not only from a product standpoint, but also from a compliance standpoint. And they want to use the cloud for this. They see it as a good use case. So essentially, their infrastructure before migration looks something like this. And it's very typical. They've got a pair of data centers with a set of physical instances that access data and a quite traditional archaic message bus that's used to communicate. One of the interesting and not very friendly things is their DR is basically done by data center. So if you lose a component, you lose a data center. The limits of scalability they've reached are, they've got a database, a very big database. Access to data is limited by access to this database, and adding computation is quite expensive. So we introduced to the firm an architecture and implemented this architecture to address some of the problems that they currently run into and unlock some of the potential that they need. I'll give a high level here and then dive a little bit into the details. And let me just pause for a second and say, if there are any questions on any of this, I'm sure others have it too. Please feel free to drop them into the chat, and we can get to them. So the core of the system is a Kafka bus, and we're moving from a database-centric view to a bus or pipeline-centric view. We can hang lots of different computation capacities off this pipeline. We can also hang a bunch of different data stores off this pipeline, and chose to do just this at the customer. What this did is not only solve a current problem, but gave a significant opportunity to address future problems as they came up. The key here was doing an MVP, or a minimum viable product, something that would solve today's problem, but also then provide capacity to solve tomorrow's problem. So the key parts of the architecture are Kafka bus. For folks who aren't familiar with Kafka, it's an Apache open source project that essentially looks like a replay log, but think of it as a distributed log with significant high-level guarantees around delivery, including exactly once delivery, repeatability, replayability. It's got and significant bandwidth and throughput. It forms the engine for allowing parallelization in the architecture, and parallelization is key to broad scale and horizontal scalability. We introduced Flink as a stream processor. It's another project, open source project, that's getting a lot of traction around message processing. And essentially in Flink, you can drop Java engines that can process messages from the bus. Instead of having a single database, we introduced multiple databases. So for near time processing, we used Aurora, which is a enterprise flavor of either MySQL or Postgres that AWS supports. We also have the ability to add other databases, building on capacities using such things as Redshift, which is a columnar database for analytics, Glue for batch, which is a version of Apache Spark for batch type processing, and S3, which is AWS's object store for the ability to create a data lake. All these things are looking at the data in different windows. All these things give either trade-offs in amount of data, processing speed, et cetera, which allows the customer to tune analytics at the appropriate timescale of consumption and data scale. So the advantages of doing this were first and foremost, scalability. The client had the ability before moving to the cloud to just do vertical scalability. They needed more processing power, they bought a bigger box. Scaling in AWS is horizontal. So they can go parallel in Auroras, they can go parallel in computation in Flink, they can go parallel in analysis in Redshift, and S3 is essentially is effectively infinitely scalable. I mentioned reliability here on this side, where redundancy was at the data center or DR level. it was a very sensible design because they knew they would run hot and could go from one to another, but failover was manual, and it put a burden on clients that wasn't easy or quick to fail over. And so we moved to a system where each component was highly available and had failover built in. Flink is built to failover. Aurora is built to failover. A common question of a few years ago that's thankfully starting to subside is the security of the cloud. And we contend and we believe that security on the AWS side was actually higher for the reasons I sort of alluded to earlier than on the on-prem side. Because once you got into the soft middle here, the world was your playground. Whereas in AWS, the system we built had encryption everywhere. Data was encrypted in flight, data is encrypted at rest, with keys controlled by the customer. So it was a very strong defense in depth architecture. And of course, by doing this, we gave them new tools that fed both needs for insights today to meet regulatory requirements, but also needs for insights tomorrow in how their products are being used and how they can innovate more quickly. One of the things that becomes interesting tomorrow as well is we go from a relational database to a distributed relational database to having other forms of data available. Because fit for purpose, as data scientists, we realize the world doesn't begin and end in a relational database. In fact, the columnar database is very interesting, as is the data lake. And I'd say the take-home message from the architecture was the pipe, not the database, is at the center of the architecture. Now, in the couple minutes I have left, talk a little bit more generally. In some senses, the approach of migrating data to the cloud as a precursor to migrating application to the cloud is sort of a, if you build it, they will come mentality. That the applications we're talking about moving to the cloud are very data rich, and in fact, as a precursor, need data available. So you need to start a virtuous circle somewhere. And the virtuous circle we started is start to stream data to the cloud. And I'll talk about methodologies for this in a minute. But essentially, once you start streaming data, you can move applications that depend on that stream, process those applications, which tend to produce more insight and more data, leading to more streaming. And you achieve value front-loaded. You also achieve value iteratively, that every iteration leads to more value. And this forms an awfully nice business case and selling point to doing such an endeavor.
Hey, Peter.
Sure.
Let me jump in real quick. I think there's a couple very excellent and timely questions. So Vera asked, is the data processed from Kafka simultaneously written into OLTP and S3? And does reading and writing such huge data volumes in S3 have performance implications?
Excellent question. So one of the beauties of Kafka, I'll answer it at high level, and then we can break out for lower levels.
Yeah, and by the way, sorry, Peter, we will be in a breakout booth session right after this, so feel free to join that. Sorry, go ahead.
Cool. So worthwhile to mention to Kafka is its ability to have high levels of concurrency. So we can have readers and writers simultaneously pulling messages of Kafka off Kafka without impact to without increasing latency or decreasing bandwidth. And so that's what we did. We have listeners for injection into the relational database and have a Kinesis cluster for doing that in a highly parallel fashion. Writing to S3 simultaneously doesn't impact Kafka and doesn't impact Aurora. So we have a separate cluster for actually doing that. Bandwidth into S3 hasn't proven to be a problem. The amount of data we're talking about is measured in probably tens of megabits per second. up to about a gigabit a second, which is well within well within bandwidth requirements of S3. And there's some tricks you can do to increase that as well. For larger volumes, more than gigabits, it does become an issue.
And one follow-on question from Darren about the data. Is it the clients, has all of that data been moved to the cloud, or will some of it be maintained inside the data center?
So there are reasons for this particular client, and as a general case, there are reasons sometimes to maintain data centers after such a migration. There are some things that this client does that are very, very latency sensitive, where we've got, let's say we had measured in tens of milliseconds into AWS across a direct connect link. For the large majority of their applications, that doesn't matter. For a small subset of applications, that does matter. So they'll maintain in a colo setup some on-prem data processing. We're in the process with the client of evacuating their legacy historic data, and that'll eventually only live in AWS. There's no reason for them to keep that on-prem, and it actually introduces, because the firm's got a very decent legacy, it introduces significant cost that we should alleviate by the move to AWS. So let me, actually, I'll skip this for purposes of time just to say, the way we talked in the use case of one way to get data to a cloud for processing, but there's many. There's change data capture, which is the most common in what we've used here, where you either pull changes off of a pipe or out of a database, but there are also more traditional means like replication, straight upload, or some sort of syncing. Let me end with the following point. The complexities of using the cloud that I've talked about here, and some of the architecture I've talked about here, become most applicable when we move out of the research lab and out of research utilization of data into production utilization of prediction. And by doing that, we introduce a whole bunch of complexity. Managing those complexities is a first-class problem and needs to be done at the beginning of a project, not end of a project. We strive to create applications that are, and architectures that are well architected, which is a buzzword, but to us, and it's actually an AWS term, really means trade-offs between manageability, security, reliability, performance, and efficiency. It's always a trade-off. And so a well-architected application means you make these trade-offs in a way that's most optimal to solve the problem. Knowing that where you start in a legacy environment can be wildly suboptimal. So this is sort of a summary architecture of what we've talked about with various components. And again, center of it is in a bus, and this forms the center of applications that allow us to derive insights, allow us to do multiple forms of processing, of visualization, and multiple forms of storage.
Wonderful.
And with that, I'll turn it back over. Thank you so much for your attention.
Peter, that's on me. I thought you were done. We do have, let me see here, 1 minute to go. So I want to give a brief thank you again to our speakers today and everyone for being here. Thanks to Sumo Logic and Risk Focus. Pardon me, I did have a typo because turns out I'm human in the session notes I sent over. So if you want to keep the conversation going with Risk Focus, who we just heard from, head over to the Tech Showcase right now from 11 to 12 to keep chatting with them. Get to hear from some more of our sponsors of the event, like DQE Communications, JetStore, Click, and again, Risk Focus. Other sponsors will be in their booths to connect with you and answer questions with some general networking in the networking room. You can head over to Sched for any link that you need. And finally, tomorrow at 9 a.m., we will return with a very special panel discussion on AI empowering cities and infrastructure, sponsored by the Consulate General of Canada in New York and Pittsburgh. So that is it for me. Everyone, thank you for being here. Thank you again to our speakers, and we will see you again tomorrow.
Thanks, Allison.
Thank you.